we did one question based on Coulomb's law, right?
Yes.
Now let us do one more problem, which is based on Coulomb's law. So let us say that yes. So let us say that the charges are. So what happens when the charges are doubled and the distance between the charges is half, right? Okay, so then what would be the force? Right, so to solve this problem, let us break this problem in two parts, right? So first we calculate what was the original force, right? So these were two charges, right? And the separation between them was some r, right? So then what was the Coulomb force? This was K Q1 Q2 by R square, right?
Yes.
Now what happens is that you double the charge, right? So Q1 becomes Q1 prime, which is 2Q1, right? And then Q2 prime, which is 2Q2, right? And R prime, which is R by 2, right? So you change your charges and the separation like this. So your F prime would be how much? This would be K Q1 prime Q2 prime by R prime square, right? And now we can plug the value of Q1 prime. So Q1 prime is how much? This is 2Q1, right? Q2 prime is 2Q2. And then R prime is R by 2. So R by 2 whole square. So then we will get, so this 2 is 4, Q1, Q2, right? And then R square by 4. So this 4 comes in here, right? So this will become 4 into 4, 16, K Q1 Q2 by R square, right? And can you identify this term? So this term. This is the old force, right? So this is the old force, right?
Yes.
So now what would be the force? So your new force, which is F Coulomb, this would be 16 into old force, right? So your force would be 16 times the old force, right?
Yes.
Yes, so hello, Mariam and Aisha, this is the first class for Mariam, right? So can you please bear with us for, let's say, 5 minutes, then I can quickly revise what we have learned so far. Is that okay with you, Aisha?
Yes.
Yes. So Mariam, up to this point, we have, let me give you a quick recap of what we have learned so far. So we are doing the first chapter, which is electric charges and field. And up to this point, we have, so let me recap. Okay. So we have learned so far about the definition of charges, right? So definition of charge is what? That it is the intrinsic property of material by virtue of which we experiences some electric force or energy and so on, right? So this is the definition of the electric charge. And then we learned about the properties of the charges, right? So in the properties of the charges, we learned about that total charge is the integral multiple of this small charge, right? Where E is the charge on one electron, which is 1.6 into 10 to the power minus 19. Right. This is called the quantization of the charge. Right. And second property we learned about the addition of charges. Right. That you can do the algebraic sum of the individual charges. So the total charge is the algebraic sum of the individual charges. Right. Which means that, let's say, if in a system, let's say this is plus 4q plus 4e, and then this is minus 2e, and then this is 3e, right? So the total charge would be plus 4e minus 2e plus 3, right? So this would be 7 minus 2, 5. So this is the algebraic sum, not the vector sum. And then we learned about the conservation of the charges. Right. And in the conservation of the charges, we learned that charge can neither be created and nor be destroyed. It can only be conserved, right? Okay, and then we learned about the invariance of the charges. So in the invariance of charges, we learned that it charges, the magnitude of charge doesn't depend upon the velocity, right? It does not depend on the velocity, right? Velocity of reference frame, right? So these are the basic properties of the charges we learned, and in the last and there are some features of the charges as well, that it is a scalar quantity. The smallest charge that a material can have is what, plus E or minus E, and then the unit of the charge is Coulomb, right? So these are the basic features of the charges. And lastly, in the previous class, we learned about the force between two charges, right? So this force between two charges is explained by the Coulomb's law. So Coulomb's law states that your force is directly proportional to the product of the charges. Right, this first charge, this is the second charge, and this is the separation. So this is inversely proportional to the square of the separation. And when you remove the proportionality, so there would be a constant, and this constant k is 1 by 4 pi epsilon naught q1 q2 by r square, where this is the permittivity of free space. So this much we learned in the previous class, right, Aisha?
Yes, sir.
Yes, so Mariam, we are continuing with this, and we were doing some questions, right? So in the first part of the question, we did that if we change the charges so much so that we double the magnitude of charge and distance between them is halved, right? So then what would be the force? So we calculated, so we double the charges, right? And the separation between them is halved. So then we calculate the force from the Coulomb's law. And we saw that the magnitude of the new force would be 16 times the older force, right? So Asha, were you noting down this part? Did you note down this part, this question?
Sir, can you repeat sir, this question?
Yes. So in this question, the magnitude of the charges doubled, right?
Yes, sir.
So let's say the previous charge was Q1, Q2, but somehow you double the charge, which is 2Q1 and 2Q2. And
Okay.
the separation between them is half, right? So the new separation is, so we have decreased the separation, right? So the new separation is R by 2. And this is Q1 prime, Q2 prime, right? So then we calculated the new force, new Coulombic force. And when we put the value of Q1 prime and Q2 prime and R prime, so we got this force, which is somehow related with the older force. This is 16 times the older force. Right, so please note this down. Asha, did you note this down?
Yes, sir.
Okay, so Mariam, if you want to
Yes,
note
sir,
it
I'm
down.
noting, sir.
Please. So whenever you have noted down, please tell me, then I can scroll down the screen, right?
Yes, sir, can you scroll down, sir?
Yes.
Yes.
What- Okay, noted.
Yes, sir, done.
Yes. So in this part, Asha and Mariam, what we did, we learned about the Coulomb force when there was a charge, right? Q1 and another charge is placed around it, right? Q2. So we learned about this force due to this charge, right? Q2 charge, one charge, right? So this was the separation. And we learned about that Coulomb force would be, the magnitude of this force would be K Q1 Q2 by R square, right? And the direction is, so if this is this is the charge which is putting a force on this Q1, so this would be in this direction, repulsive force, right? If the charges are same, right? So this would be FQ2, right? And what happens when you have multiple charges, right? So let's say if this is some Q and you have Q1 charge, Q2 charge, let's say Q3 charge, and then you have Q4 charge, right? So when you have multiple charges, so then what would be the total force on this charge, right? So to learn this, we need to learn about the superposition principle. Okay. So when you have let me change the color of the blue. So the force, on a charged particle due to the multiple charges, right? And this is given by this superposition principle, right? So what is the superposition principle? So this is given by the superposition principle. Right, and what does this superposition principle says? So let's say that this is the charge, right? And this is the separation 1, R1. So this is some Q charge, and this is Q1 charge, right? And let's say you have another charge, and the separation is R2, and this is Q. Right, let's say you have another charge. So this is R3 and this is Q3. Right. Similarly, we have multiple N charges. Right. So this is Qn and this is R. So superposition principle says that the total force on this charge would be the vector sum of the individual charges. Right. So in the previous class, or just a moment ago, we learned that the charges obey the algebraic sum of the individual charges, right? So charges obey algebraic sum, right? But the forces between the charges obey the vector sum, right? So this is about the superposition principle, right? Superposition principle says that the charges on this, the force on this charge would be due to the sum, vector sum of the individual charges, right? So this will repel this in this direction. So this is F1, this is F2, this is F3, right? And this would be Fn. So the force would be the vector sum of F1, then F2, then F3, and then F, right? So this is how you calculate the force on this charge, test charge, right? So let me write the superposition principle. So it states that force on the test charge Q would be the vector sum of all the individual forces, right? Okay, so are you guys noting it down?
Yes, sir.
Okay, so where should I put this screen? Is that okay?
Yes, sir.
Okay, so please note this down, and then now the important thing is coming here is the vector sum, right? So let us discuss how do we calculate the addition of the vectors or the sum of the vectors. Okay. we will learn about, so you guys have learned about the vectors in your previous class, right? 11th class, you guys have learned. So let's just do a small recap of what you have learned in your vector classes. Okay. Yes, so if you guys finished noting, then tell me, then I will move on.
Yes, sir.
Yes, Aisha, did you finish noting?
No.
Yes. Yes, so now the important quantity is vectors, right? So let us recap of vectors. Right. So you know that any vector can be represented by two quantities, right? What are those?
Scalar and vector product.
Yes.
Scalar and vector product.
Vector theorem, I didn't understand. Yes, did you say the vector theorem or?
Almost I was saying scalar and vector product.
Okay, any vector with its magnitude, the magnitude. So is this what you were saying, Aisha?
Yes, sir.
Yes, yes, so that is correct. Sorry, because I couldn't hear you properly. Right. Your voice was lagging or some, I didn't understand. Yes. So yes, so you can represent any vector by its magnitude and this direction, right? And this is called the unit vector, right? So unit vector just tells about the direction. So let's say if this is some vector, right? So in this direction, you have one unit vector, which will tell about the direction of this vector, right? So, and the magnitude of this unit vector is how much? This is 1, right? So universally, you represent 3 unit vectors, right? So those are called the universal unit vectors. So universal unit vectors. So if you go, so you have in 3 dimension, you have 3 directions, right? X, Y, Z directions. So if you go 1 unit in X direction, right? So this is your X direction. And if you go 1 unit. So this is called the ith direction, right? I hat direction. And if you go 1 unit in Y direction, so this is called the J cap direction, right? J unit vector. And if you go 1 unit, so if you go 1 unit in Z direction, so that is called the K, right? So I, J, and K, these are called the universal unit vectors. Okay.
Yes.
And the magnitude of all these vectors is how much? This is 1, right? And second property is that they are orthogonal. Orthogonal means they are always perpendicular to each other, right? So let's say if I go 1 unit in, let's say 2 unit in X direction and 3 unit in Y direction, and then let's say 4 unit. So 4 unit in Z direction, right? So then what would be my position vector? So this would be 2 units in I direction, 3 units in J direction, and 4 units in K direction. Right. So this would be my position vector. Okay. And you can represent also with the coordinate. So what would be the coordinate of this point? So this would be 2, 3, and 4. Okay. So this is how you represent the position vector in the universal unit vector form, right? So you can write any vector in the universal unit vector form. So that would be AXI plus AYJ plus AZK, right? So this is the universal unit vector form of a vector, right? And what would be the magnitude of this vector? So this would be simply AX square plus AY square plus AZ square, right? So this is the magnitude of the vectors in the universal unit vector form, right? Okay, any question up to this point?
No.
So do you guys want to note down this part, because you guys already know, right? So are you guys noting this down? Do you want to note this down?
No.
Okay, so let me go ahead and talk about the addition of vectors, right? So let's say vectors are given in the universal unit vector form, right? So let's say A is given like so A is given like 2I plus 3J plus 4K, right? And B is given like 3I minus 2J plus 7, right? So then one would ask, what would be the addition of these two vectors? So the addition of vectors simply be, this would simply be I with I. So this would be 5I hat, this would be J hat, and this would be 11K, right? So doing addition in the universal unit vector is pretty easy, right? Then we can calculate the magnitude of this vector. So magnitude of this vector would be how much? This would be simply 5 square and 1 square and 11 square, right? So this would be how much? 25, 21 is 46, and then 47, right? So calculating the addition of vectors in the universal unit vector form is pretty easy. But what happens when you are given the two vectors? So two vectors in polar form, right? So then what would be the addition of vectors? So let's say this vector is given, right? And this vector is given, and the angle between them is given. So this is called the polar form, right? So then what would be the addition of the vectors? Okay. So you guys have already learned about the parallelograms law, right? So in polar form, there are two methods, mainly two methods, right? Both gives the same result. So whichever method you want to choose, you can choose any of them. So one method is called the parallelograms law, right? And the other method is the triangles law, right? So in parallelograms law, what do you do is that let's say So any vector, this has geometrically two parts, right? This is called the tail of the vectors. Right. And this is called the head of the vector. Right. So when you place in parallelograms law, what you do is that this is one vector, this is the second vector, right? So you take this B vector and draw a parallel B vector on this head of the other vector. So you take the tail of this vector in here and you draw a parallel exactly as B, right? On the head of this vector. Okay. And then again on the head of this B vector, you draw the parallel A vector, right? So this is A and this is B. So this is looking like a parallelogram, right? And when you draw the diagonal, so this gives the resultant of the two vectors, which is A plus B. Right? Right, guys?
Yes, sir.
So this is called the parallelogram law. Okay, you make a parallelogram and then you draw the diagonal. So the diagonal will be the resultant of the vectors. And similarly, we have triangles law. So when you keep the tail of the other vector on the head of this vector, right? And when you join the tail of this vector to the head of this vector, so this will give you the resultant. So this is from the triangles law, right? So this is triangles law. And this is the parallelograms. Any one you can choose. Right. So then what would be the magnitude and the angle, right? Because vector has two parts, magnitude and angle. So what would be the magnitude and the angle from this addition of vectors? Okay, when you are given the polar form. So let us calculate that. So this is A vector, right? This is B vector, and this is, so this is B vector, and this is the result, right? So this angle is the angle between A and B is theta, right? And you know that from the resolution of vectors. So vector has two components, right? This is theta, this is B. So vector has two components. This one is the horizontal component, and this one is the vertical component. Right, so horizontal component is how much? This is B cos theta, right, which is Bx. And this is the vertical component, which is what? B sine theta, right, which is By. So you can write any vector in the horizontal component form and the vertical component form. Right. So this would be how much? B cos theta I hat, and this would be B sine theta j. Right. Okay, any doubt in this point?
No, sir.
Yes, so this B vector has this vertical component. So this would be how much? This would be how much? Vertical component.
Sine.
Yes, B sine theta. And this is the horizontal component. So this would be B cos theta. Right, guys? So now we had made the right angle triangle. Now from the Pythagoras theorem, we can calculate all the values, right? So let us make the equivalent triangle. Right, so this is A plus B cos theta. right? This is b sine theta, and this is the resultant. This is the angle between the A vector and the resultant, right? So first we need to calculate this magnitude. Okay. So this would be using the Pythagoras theorem. This would be how much? R square would be perpendicular square, right? Plus base square. So this would be how much? B square sine square theta plus this is A plus B whole square, right? So this is A square plus 2AB, right, plus B square. Okay. Now B square sine square theta, B square cos square theta. So B square is common. So what is sine square theta plus cos square theta identity? Do you guys remember what is this identity? Yes, 1, right?
Mm.
So this would be how much? A square plus B square plus 2AB cos theta. Right. So the magnitude of the resultant would be, so this is R square, so we can take the square in this side. So that would be root. So this would be A square plus B square plus 2AB cos theta, right? So this is the magnitude of the addition of vectors in polar form, right? And what would be this angle? So tan alpha is perpendicular upon base, right? So perpendicular by base. And perpendicular is how much? V sine theta. And base is how much? A plus B cos theta. Right, so tan alpha would be B sine theta and A plus B cos theta. Right. Okay, so you guys knew this already, right?
Yes.
So do you guys want to note this down?
Yes, sir, I noted.
Okay, so note that. So where should I put the screen? Should I scroll up and
Sir, I noted it.
okay, so note this down, and then we will do the subtraction, multiplication, and then we'll come again to this superposition principle and then equilibrium. Yes, noted. Mariam, did you note it down?
Yes, sir, I have already noted.
Okay. Okay, so let us move ahead and understand about the subtraction of the vectors. So for the subtraction of the vectors, what you do is that okay. I will quickly write the results. So for the subtraction of the vectors, what you do is that you take the anti-parallel. So if this is the A vector, so what would be the anti-parallel of this vector? So if you take the opposite direction of this vector with the equal magnitude, so this is called the anti-parallel, right? Right, so this is the anti-parallel. So similarly for the subtraction of the vectors, this is A, this is B, right? So you take the anti-parallel of this vector with the same magnitude, right, which is minus B, and then you apply this parallelograms law. So you take the parallel, you take the parallel here. So this becomes the parallelogram and you draw the diagonal. Right, so this R is A minus B. Okay, so this is, and the resultant of this subtraction comes out to be this. And the direction is simply this. Any doubt, guys?
No, sir.
Okay. So then you have the multiplication of two vectors. Okay. And then we will quickly jump on to what we were learning in the electric charges. So multiplication of the two vectors. Okay, so if you have two vectors and you multiply them, so there could be two results, right? One is that the product is scalar. Right, if you multiply some two vectors and the product is scalar. And the other results could be that product is vector. Right, so this is called the dot product or the scalar product. And this is called the vector product or the cross product. Right. So I'm just recapping what you guys have learned in your previous 11th class, right? Just revision, quick revision. Am I going too fast?
No.
Okay. So what did we learn about the scalar product? So a scalar product of two vectors is defined like this. You take the dot product and you get a number, right? So this is the scalar product, right? And let's say if you have vectors in the universal unit vector form, right? And B is then the product dot product would simply be AX BX plus AY BY and then AZ GZ. Right. So this is the dot product, right, in the universal unit vector form. And this is very important in calculating the angle between two vectors, right? This is very important. Okay, and the next product, next multiplication is the vector product. Okay, so in the vector product, this is defined like this. So this is A, B sine theta, and this must have some direction. So that is defined by this n. So n hat is the unit vector, which tells the direction of the cross product. And this is calculated with the help of the Maxwell's right-hand thumb rule, right? So if you place the if you place your palm in the A direction, right? And when you roll your hand, the rest of the hands, your palm, so the direction that your thumbs gives, right? So that is the direction of the cross product. So in this case, the cross product is coming out of this plane, right? So this would be the direction, right? So this direction shows that the vector is coming out of the plane or the board, and this direction shows the inward direction. Right? This is inward and this is outward. Okay, oh, give me 1 minute, please. Okay, so this tells about the outward direction, right?
Yes.
Any doubt up to this point, guys?
No, sir.
Yes, so you can calculate the matrix, you can calculate the vector product from the matrix multiplication also. Right, so A cross B is given by this. Right, so this is the matrix multiplication method for the cross product. Okay, now the revision of vectors is over, right? So let us do one question which is useful from the vectors point of view, right? So let's say that two forces are acting, which is force one is in this direction, right? And force two is in this side. And the angle between them is 60 degrees, right? So, and the magnitude of F1 is, let's say, 10 Newton, and this is 20 Newton. So what would be the magnitude of the resultant vector, right? So you guys already know that the magnitude of the resultant would be how much? This would be F1 square plus F2 square plus 2 F1 F2 and cos of 60, right? So this would be how much? 10 square plus 20 square plus 2, 10 into 20, and cos 60 is how much? 1 by 2, right? So this 2 cancels, and we have 100 plus 400 plus this is how much? 200. Right, so 4, 3, and 7. So 10 root 7, right? Newton. So this is the resultant force. And what would be the angle? So the angle would be simply B, which is F2 sine 60 by A, which is F1 plus F2 cos 60. Right, so this is F2 is 20 root 3 by 2 by F1 is 10 plus 20 half. Right, so this is 10 and this is how much? 20 root 3 by 2 by 20. So 20, 20 cancels and we have root 3 by 2. Right. So this is the answer. And your alpha is how much? Alpha is tan inverse u3 by. Right. So is this clear, guys? Any doubt up to this point?
No.
So please, guys, note this down. And from the next class, we would be doing the equilibrium, and so we'll be moving on with this electric charge, right? So in the next class, we'll start from the equilibrium. Okay, we did the superposition principle. We learned about the parallelograms law and all. And in the next class, we will be using these vector properties, right? So you guys please note this down, and then we'll meet in the next class. Okay.
Okay.